In this video, we're going to talk about the properties of acids and bases, and this is going to be our part 2 because in our last video, in part 11, we talked more about acids and bases, but it was just like a little introduction. So today we're going to expand more on top of that. And this is also our part 12 video inside of chemistry, chapter 2. So some things that we're going to cover is more about bases, because in our last video we talked more about acids. We're also going to talk about different ways to measure pH and some other examples as well. So let's get started with this video. So first of all, we're going to start off with a did you know fact. So here's a scientific fact about water. So pure water has equal quantity of hydrogen ions, which is H+, and also hydroxide ions, which is OH-. So in a sample of pure water, the quantities of these two ions are equal. So what we're trying to say here is that if we remember the pH scale, pure water has a pH scale of 7. So that means, since it has a pH scale of 7, that means it has an equal quantity of hydrogen ions and also hydroxide ions to balance it out. So since they're balanced out, that's why we have an exact pH value of 7. But for example, if we had a little bit more of hydrogen ions, or if we had a little bit more of hydroxide ions, then it wouldn't be balanced. So then we'd have maybe a pH scale higher than 7 or a pH scale of less than 7. So pure water has exactly the same quantity of hydrogen ions and also hydroxide ions. So this was just a little kickoff to start off this video, and now we're going to move on to the actual stuff that we're going to learn about. Now we're going to talk about bases. So in our last video we talked more about acids and Arrhenius and what he said about acids, so that's why today we're going to talk about bases. So Arrhenius categorized a base as a substance that dissolves in water and releases hydroxide ions, which is OH-, into the solution. And a solution of sodium hydroxide, for example, denoted as NaOH, will exhibit basic properties. So what Arrhenius said is basically, if you have a base and if you dissolve it inside of water, then it's always going to release a hydroxide ion. So that's why inside of bases, you're always going to see OH, which means hydroxide. You're always going to see that in every single formula. So for example, of sodium hydroxide as here, we can see that it has OH. And for any other base, you're always going to see that OH. If we do a quick recap of our last video, which was the acid one, in acids, they're always going to have a hydrogen ion. So in bases, there's OH, and in acids, there's always going to be just hydrogen. So the formula is NaOH in this case for sodium hydroxide, NaOH, and then what happens when you put it into water, it splits, and then you just get a sodium ion, which is Na+, and the hydroxide ion, which is OH-. So this is what Arrhenius said about bases. So here are some common bases, and we're going to look at these and try to remember the formula and also the name for these, because if you can do so, it would really help. So if you're just starting off chemistry, you're always going to see these common bases as an example that the teacher might give you. So that's why it's really important that you can try to remember the formula and also the name. So the first one is sodium hydroxide, and the formula is NaOH. And the common name is Li, and it's most widely used in industrial bases, and usually you can find them in drain cleaners. For our second one, we have potassium hydroxide, which is KOH, and the note for it is it is used to make some liquid soaps. So in our previous video, we learned that most bases are actual soaps, so you can see that all of these usually are used in cleaning products or soap. And for our third one, we have calcium hydroxide, which is Ca, and then hydroxide in brackets, OH, and 2 of those. And then this is used to manufacture paper and also cement. And for our next one, we have magnesium hydroxide, which is Mg, and then 2 hydroxide ions. And for the notes, it's not really soluble inside of water. And for our last one, we have ammonium hydroxide, and ammonium hydroxide is NH4OH, and it's used to make fertilizers and cleaning solutions. So since we can see that there is nitrogen inside of it, nitrogen is always used from plants, so that's why it is used in fertilizer. So from our previous slide, if we remember what Arrhenius said, he said that if you dissolve it inside of water, it's always going to release OH, hydroxide ions. So that's what you can see in every single one of these bases. You can always see OH. So you always see a hydroxide ion in every single one of them. So if you see an OH inside of a formula, you should immediately know that it is a base. So these are just some common bases that you can try to remember, and for the formula and the name. So moving on, now we're going to talk about indicators and also pH. So many acids and bases are colorless when they're actually dissolved in water, so that means you can't really see them. So since you can't see them, this makes them appear safe, even though there might be huge hazards inside of it. So you're not going to be able to see these hazards because they look clear just like water. So to safely determine the acidic or basic nature of a solution, we should always use an acid-base indicator. And there's many different types of acid-base indicators that we can use. There's some cheap ones, there's some expensive ones, but we're going to look at some of them now. So the first one is litmus paper. So on the right here, here's an example of litmus paper. So it just looks like this type of a piece of paper. It's yellow, but what happens is that when litmus paper is put inside of an acid or a base, it's going to either turn red or blue. So it turns red when the stuff or the mixture is acidic, and it's going to turn blue if it's basic. So for example, if I were to dip this into an acid, then it would turn red. If I were to dip it inside of a base, then it would turn blue. So litmus paper is one of the acid-base indicators that you can use for experiments or for safety. And moving on, for the second one, we have the pH scale. So chemists determine the acidic or basic nature of a solution by using the actual pH scale. So this is how the pH scale looks like. It ranges from 0 to 14, 7 being neutral. So above 7 would be a base, below 7 would be an acid. So solutions with pH below 7 are acidic, while those above 7 are basic. So this is another way that you can use to actually measure the pH of an acid or a base. And finally, for the last one we have is the pH meter. So the third method uses a pH meter, which measures an electrical property of the solution that varies with pH. So the pH meter is the most efficient way. So basically it's going to tell you the exact pH to the decimal point. So you can see here that it's going to give the exact point. So when you dip this arm into the solution, it will give you an exact pinpoint of how much it is. So for example, you can see that this one is at 7.16, so it's pretty much neutral. So the thing is with these, so if we look at litmus paper is the cheapest, but also it's not always the best because you're not going to see the exact value, but it will still give you a relative idea of how much it is acidic or basic. But if you were to use this pH meter, you're going to see it exactly to the decimal point. So these are 3 things that you can use to measure the pH of acids and also bases. And now we're going to talk about the properties of acids and bases. So starting off with the taste, in acids, they're always sour. As we learned in our last video, acids are sour and bases are bitter. And some examples of acids are lemon, vinegar, lime, and some examples of bases is tonic water, so it has a bitter taste. Now for the property of feeling, acids can burn skin, and bases can also burn skin, but it also feels slippery at the same time. And some examples of bases is soap or sodium hydroxide, and for acids is sulfuric acid. And now for some indicator tests, we know that if we have a litmus piece of paper, if it's just a piece of paper that we dip in acids, it's going to turn red, or even if it's already blue, and if we were to dip it inside of acid, then it'll still turn red after that. And for bases, if we had a normal piece of paper, then we were to put it, then it would turn blue, or even if we had an acid already put into it, and then if we take it out and put it inside the base again, then it's going to turn blue. And for some chemical properties, both of these lose acidic or basic properties when they're mixed together. So these are just some properties of acids and bases. So to sum everything up, so we talked about the definition of bases in this video, we talked about the different measurements of pH methods, and we also talked about the properties of acids and bases and a table that showcased all of that. And in our next video, we're going to discuss the naming of acids and bases and some examples of them. So that summarizes everything for this video. So thank you so much for watching from Try to Be Useful, and we'll see you in our next chemistry video.